This problem looks easy, but it's quietly testing whether you understand string handling in Go. If you use plus equal to carelessly here, you might be writing order of n square code. Let's fix that. We are given two strings, word1 and word2. We need to merge them by alternating characters. First from word1, then word2, and then again word1. If one string is longer, append the remaining characters at the end. For example, let's say word 1 is ABC, word 2 is PQR. Then output should be take first character from word 1 A, then from word 2 which is P, then again from word 1. Now continue from word 2 Q, C and R. This should be the output, right? Clear alternation. Let's check the other example. Word 1 here will be AB, and word 2 will be having more characters than the word 1. Okay, then yeah, then repeat the same process. Take the first character from word 1, and then from the word 2, say, which is A and P, then again word 1 B, from word 2 Q. Now if you notice, we have exceeded the word 1 length, so just simply append the remaining characters from the word 2. Okay, which are rs. Let's think about how to implement this cleanly. Imagine two pointers. Okay, let's say we will take the first example. Imagine two pointers. Pointer I starts pointer I will be at the first character from the word 1, and next pointer will be pointer j, which will point to the start of word 2. Okay, step through, let's say step 1 is basically I is 1, j is p. Okay, then result becomes ap, right? Step 2, we'll move that pointer ahead from both. Now calculate the result. I is b, then j pointer is basically q here. Then again move I, step 1 again, for same for j also will be incremented. Now calculate the result, which is c and r, right? So now our results become ap bq cr. If word 1 was longer, let's say pqrs, after ab pq cr, I will be exhausted, right? J still has s left, so we append the remaining characters. So in that case, our result will become this, j will move ahead. That's the entire pattern. Walk both strings together. Whoever has leftovers gets appended. Now let's implement the solution. First take the result I'm taking result as byte. I will explain why I've taken it as a array of bytes instead of string. Okay. Then we'll take two pointers as I explained in the approach. Both will be pointing at index 0. Okay. For I less than length of word 1 or j less than length of word 2. If so here we are checking both the pointers against the both the word length, because we need to continue till we exhaust one of the string length or the both. If I less than length of word 1, then result is equal to append result word 1 word 1 so word, word 1 of I. That's what we need to append, and then move the I pointer ahead. If j less than, let's simply copy change from I to j word 1 to word 2 j plus plus, right? And at the end simply return the string, convert the array of bytes into string and simply return. Okay. Now call that function within the main function. Word 1, let's say abc, word 2, let's say pqr. Okay. So yeah, come back to where I'm using a byte slice here instead of string concatenation, because Go strings are immutable. If I used like result plus equal to string word 1 of I, for example, then each operation would create a new string, right? Because strings are immutable in Go. That makes it quadratic. This slice approach keeps it linear. Let's execute the code to check if it runs properly. Okay, so the output is a p b q c r. So yeah, so output is correct, right? A b p q c r. Okay, if one of the string has less character, then let's check that scenario. In that case our answer becomes a p b q and r. If it has, let's say, word 2 has one some more characters, then it will get abandoned at the end, a b b q and the remaining characters from the word 2, right? So this is how the solution will be. So let's calculate the time complexity. Yes, here the time complexity will be order of m plus n. We visit each character once. Space complexity is also order of m plus n, because we build a new string. Now regarding the pattern recognition, here is the pattern to remember. If a problem says alternate, interleave, merge two sequences, think two pointers, one pointer per input, And notice something subtle. The loop condition is or, right? Not and, because one string may still have characters left. That phrase, append the remaining characters, tells you exactly how to design the loop. Now let's see how do we explain it in an interview. In an interview, I would explain it like this. I will use two pointers, ing, one for each string. I iterate while either pointer is valid. At each step, I append from word 1 if it if in bounds, then from word 2 if in bounds. If one string is longer, the loop naturally appends the reminder. Time complexity will be order of m plus n. Space complexity will be order of m plus n. And since I am using Go, I avoid string concatenation to prevent quadratic behavior. That's the complete answer. This is the two pointers on two subsequence pattern. So what is the pattern name here? Two pointers on two sequences, right? You will see it again in merge sorted arrays, compare version numbers and zip style problems. Next video we'll look at two pointers on the same array, and that's where things get more interesting. Subscribe if you want structured DSA in Go. Thank you.